just recklessly abandon security just because you have insurance, right? You still have to make a strong effort to be secure, to have a secure application, secure your data, et cetera. So where we wanted to focus was there's this kind of perception that if you lift and shift infrastructure from on-prem to cloud, all of your security problems go away or are severely mitigated. There's some truth to that. There are some security things that get easier, but there's also a lot of new security considerations and new risk that you incur. So we wanted to go over some specific examples of here is something that was moved and here was a security hole that if you look at it from a 10,000 foot view, it looks absolutely fine. But when you dive in, come to find out there was a problem. So I'm going to cover more on the application side. And my name is Joe Rose. And like I said, Bill introduced me already. And then I'll turn it over to Clive and he'll get more into actual networking and infrastructure. So the four examples I'm going to go over, I'm going to present the application to you. Here's how it was built. Here are the different components, and here's how they're tied together. And then see if you guys can't figure out where the security vulnerability is. All right, so we had a mobile application. The purpose of what this mobile application was being used for in this specific case was looking up order history. And it had two forms of secure identification. One was a client key, and that client key was embedded in the mobile app. So it's not impossible that someone could take that mobile app code and extract that client key, but it certainly made it more difficult. Your average run-of-the-mill hacker is not going to be able to easily extract out that client key off of that mobile app. So it adds a level of obfuscation. The other component that it had essentially was an IAM key. So the mobile app user would log in to the identity system and get back an identity token. So when the mobile app called into the enterprise service bus, which then went to fetch the order history, it would present those two things. It would present the client key. So we have some degree of certainty that it actually came from the mobile app. And then it would also present the IAM key, which is, hey, we're now an authenticated user. So does anyone want to venture a guess as to where the security hole was in this?
Between ESB and order management.
It was. What specifically, though?
Because you have both keys.
That's a good thought. That wasn't quite what it was, but that's a good thought. Anyone else? So the security hole was because the identity system doesn't talk directly to the order management system. There was no validation that the order history you were looking at was yours. There was this assumption that I've established an identity and I've established a source and I've done both of those things, therefore I'm okay. What they didn't actually do is look at, you could put in any order number you wanted and you could see anyone else's order history. So there was this perception, this feeling of safety of, we've done everything right. We've got client keys. We've got identity keys. We're on the cloud. We're using a cloud-based service bus. Everything is as secure as it could possibly be. And again, that was the big hole. So you could literally set up a scraper and just run every order ID between 0 and 1 billion and just get their shipping address, their credit card, last four, everything. So that was the first scenario. All right, second scenario. So the focus on this one is everything encrypted? What we want to make sure is when we go from our file-based process to our cloud-based process, do we ever have data that's not encrypted anywhere in the chain? So the original process was a file upload to an on-prem server. There's some crunching that happens, and then it gets sent to and from the POS system. So the new system was essentially the same thing, but it happened over Amazon Kinesis. It happened with API Gateway in between. All the connections in between were secure. The data was encrypted at rest on the customer master. The data was encrypted at rest on the POS. Does anyone have a guess as to where the data was not encrypted somewhere in that stream?
In transit.
In the Kinesis stream, that's absolutely right. So in transit, it was encrypted, and that's what was deceptive about it. It was encrypted at rest in customer master, encrypted at rest in POS. In transit, it was encrypted. It was SSL, was a secure protocol. But without having a deep understanding of how Kinesis works, you would fail to realize that actually stores data on disk. So a Kinesis stream is stored on disk, and that disk is not encrypted. And at the time this was built, Kinesis didn't support encryption. It does currently, which is a good thing, but at the time this was built, Kinesis didn't support encryption. So if you're going to lift and shift to the cloud, you can't come in with a remedial knowledge or basic knowledge of how each system works under the hood. So my point here being that you can't just fire and forget and assume the cloud's got your back. The underlying systems, they can introduce security holes, either not being encrypted or not requiring certain keys or something like that. So that's the second scenario here. All right. Third scenario. So this was an interesting one. This was an e-commerce system that was migrating to the cloud. And so we're going to do it in phases. The first thing we want to do is migrate the identity management system to the cloud. We'll migrate e-com later, but first thing, let's get identity management migrated to the cloud. So what are the benefits of using something like a OneLogin or an Okta, that cloud provider? Well, it's got identity management, sure. It's got bot detection. It's got fraud detection. It can detect denial of service attacks. It can detect password cracking. So the way they set this up was the on-prem server would get the request. It would reach out to the identity server, verify all the information, and then let the user go on their way. So everybody thought, hey, this is a great, much more secure than what we had before. So anyone have a guess as to what the security vulnerability in this one was? So I'll give you a clue. It's related to the fact that we're proxying traffic.
The on-prem server?
The on-prem server was proxying the authentication requests to the identity management system, yes. The cloud-based identity management system, yeah. Because this is they thought, okay, we're going to do kind of a lift and shift, little piece at a time. They're not just going to do kind of a one big bang type of thing. So the answer is, if you're not familiar with these systems, you don't know them really well, they're typically learning systems. And the way those learning systems work is they will monitor a certain amount of traffic. They will learn from that traffic, and they will determine what's good traffic and what's bad traffic. So if all your traffic appears as though it's coming from your on-prem servers, what problem does that introduce? All of your traffic appears okay. Every single request is from your on-prem servers, which the overwhelming majority of those requests coming through look fine. So the model that you trained this cloud service to use was let everything through, no problem. There's no denial of service, there's no fraud, there's nothing. Everything looks good to me because it's all coming from these 5 trusted sources. So again, it all goes back to deeply understanding how you're using the cloud service and what those capabilities are. So they thought, I have checked the box. I have got my cloud identity management system in place. I am good to go. And they didn't deeply understand how that system worked, the fact that it is a learning-based system. All right. We'll go to the final one. So this one was, and I know I didn't mention this earlier, and I should have. These were all real-world examples of problems that we came in and helped clients fix. Some of them we stumbled upon kind of doing unrelated work. Some of them they reached out and said, hey, we're having this issue. How do we fix it? So I should have qualified that from the beginning. So this one. This is another e-commerce system looking to move an on-prem solution into the cloud. And they thought their first step is, let's take the caching tier and move that to the cloud first and leave the e-commerce systems on-prem. That is a great way to do this, by the way. If you're looking to move systems to the cloud, there's absolutely nothing wrong with moving components one piece at a time. So there's nothing wrong with the overall approach. So they moved from on-prem Varnish to in the cloud AWS CloudFront. And so again, this was a PII leak. Anyone want to take a guess as to what the PII leak was? And so for this particular one, the caching mechanism used by the on-prem servers had a vary key that says don't cache things if this certain key is present. CloudFront didn't have that same equivalent. So by not having a deep understanding of their own on-premise application and how it was configured, when it was moved to the cloud, it was not noticed that the cloud functionality didn't have the same equivalent. And that's true of a lot of cloud services. A lot of cloud services are, I don't want to call them dumbed down because that's certainly not the case, but a lot of times they're less configurable. less tunable, and less tweakable. So what ended up happening in this particular case is if you logged in and went to account management and then looked at your addresses or your payment methods, you would see the cached version of that page of whoever went there first every 5 minutes. So you would see someone else's payment information, you'd see someone else's account manager, their order history, their address information. So all really driving home the point that if you're going to use these cloud services, especially if you have something really complicated you're doing on-prem, you got to have a deep understanding of how they work, or you're going to introduce all types of security holes. So that's it, Clive. Are you ready?
Good evening, everyone. My name is Clive Brown. I'm a network engineer with JBS. So I kind of drafted this presentation a few days ago, basically because of some of the things I noticed happening. And it's funny that after I drafted this, the first thing I saw in my inbox last night was an article pretty much outlining some of the things that I'm not covering here. So there was a breach involving 100 million Android users due to a faulty cloud storage sync process. So for some of the Android apps that they looked at, basically the developers are embedding connection keys for the backend cloud storage directly into the mobile application. So one of the things I wanted to do is kind of go over a few things that I see happening quite often in this industry. Some of this will be repetitive for some folks, and some folks it might be new. So one of the first things we want to talk about is containers, right? Because containers right now occupy about 84% of organizations that are using that in some kind of production workload scenario. But despite the availability of tools like Azure Key Vault and AWS KMS, developers are still hard-coding sensitive information within their config files, right? So when you look at the fact that you have 84% adoption, you can see the implication in terms of exposure and risk, right? And many of these issues can be easily mitigated without significant complexity. So when we look at Docker right now, instead of the simple way of handling the problem, so to speak, we're basically looking at using Docker secrets to basically handle your encrypted or your private data, right? So we want to use that to manage your user IDs, your password, your certs, keys, and so on and so forth, right? And this is essentially an easily achievable and provided best practice solution for a growing problem. And I say a growing problem because I see it constantly. Kubernetes is another container service that's actually growing quite rapidly right now. And we can employ some of the same ideas behind securing your data here in Kubernetes, right? The only thing we need to be aware of here is that by default, the Kubernetes actually stores the information unencrypted in like a base 64 encoded string. So it can be easily retrieved. So on top of that, we want to do is add some layers of protection, right? We want to enable encryption at rest for the secrets. We want to enable and configure role-based access controls for the rules that restrict reading and writing to the secrets. And we can utilize external key management services like Azure Key Vault or Amazon Key Management Service. These are things that, while again, some of us are looking at this as, this should be common knowledge. But from what I'm seeing right now, it doesn't seem to be happening. It's happening rapidly, pretty rampant for some large organizations. When we look at the fact that many organizations right now run a hybrid configuration for obvious reasons, right? We don't want to deal with the capital expenditure for procuring that kind of environment. We don't have to deal with the scalability of that, and we don't have to manage some of the underlying infrastructure. But when we look at some of these scenarios, we should remember that misconfigurations in an S3 bucket or an Azure storage account could be detrimental to the safety of the data that's being involved here. And a company like Impervia suffered this in 2019, right? They had a database snapshot, which was basically uploaded to an Azure RDS without security measures around it, and basically lost thousands of email addresses and custom private data because of this issue. They were basically migrating from an on-prem solution to an AWS RDS. So Unfortunately, this is not an uncommon occurrence in terms of misconfigurations that led to data breaches within the last few years. It's actually quite common. Even though we know the controls are out there, people are still overlooking some of the basic things that should be actually employed in basically reducing these issues. So when we look at some of the process here where people are going from on-prem to cloud, right? We're looking at your migration strategy and how important that is to actually have a solid strategy. So when people plan for their migration, we don't want to look at just the technologies that are being implemented, right? The strategy should look at workflow, data flow, not just from an application perspective, but consider all security implications, both egress and ingress, right? A migration strategy should include secure data transmission path, preferably over a VPN, right? The idea of an extensive plan is to go through test scenarios while looking for ways to improve the security posture and reliability of that particular plan, right? From some of the basic things we look at here, and I know some of these are commonplace, but if they were being implemented, some of what I'm seeing on a regular basis wouldn't be happening, right? Your RDS should never be public. But I've seen it happen, right? We deal with a lot of these on a regular basis where people simply misconfigure the environments, enabling encryption for your databases. And this should be a common practice regardless of compliance requirements. It's a small step, but it can go a long way in protecting you, not just now, but as your environment changes as well, right? As professionals, we focus on encrypting the data, but oftentimes overlook the security of the storage medium. Right? The more layers we have, the harder it is to peel back. So the need for reoccurring encrypted backups should also be part of your ongoing maintenance strategy. As we look to more and more cloud storage, and we'll go into an issue here that actually recently occurred here. Cloud storage misconfiguration accounts for a significant number of data breaches over the past 5 years. While cloud storage is by no means insecure in nature, how applications access that data can be. So the versatility of cloud storage is significant. It provides a significant advantage and continues to grow. And right now, there is really no limits of what we can store there. An example of what I'm talking about here is that there was a couple of dating apps that actually got their data exposed because of an S3 misconfiguration. And unfortunately, with a dating app, you're looking at pretty sensitive information that's actually getting leaked out there, right? Your sexual preferences, your pictures, your screenshots, private chats, audio recordings, and this is pretty commonplace. So when we look at how these exposures occur, we look at the fact that a lot of these occur because we have to make changes to the environments that we're managing. And the problem here is that as we make changes, we're introducing potential issues. And unfortunately, it's part of what we do. There's nothing we can do to circumvent the need for change within the organization. Configurations change on a regular basis. So basically, what do we do now to support the security of the environment as we move forward? So we look at what is commonplace now when we talk about guardrails are basically systems that are designed to catch things before they get out of hand, right? And when we talk about this, we talk about looking at how the environment is architected. For instance, we want to look at basically that's the first part of the process, is to make sure you have a well-architected environment, right? The second thing we want to look at is your controls, your operational controls. What do you have in place to actually curtail some of these mistakes from happening, right? We have tools such as AWS Guard Duty and Azure Policy that can provide checks and balances to ensure that you're not basically overriding your corporate policies. I was actually working on a project earlier on today where I set up about 15 or 20 of these to kind of mitigate some of the most common mistakes that are made in say, Azure, for instance. And these go from basically ensuring that you're forcing the application developers or anybody deploying the apps to ensure that they're using TLS 1.2. You're making sure that the databases are always private. You're making sure that storage accounts are never made public. And there's a myriad of things you can do. You can go ahead and set guardrails to make sure that you have minimal exposure, making sure that you can tie down your subnets and your VNets to ensure that somebody can't just spin up an instance and forget that by default, Azure tags it with a public IP address, and then go ahead and expose RDP publicly and not be aware of it. These guardrails are designed to basically prevent those things from happening. And some of the mistakes that we've seen happening in some of the cloud services today are basically because there are no guardrails in place. And we're human. We all make mistakes. So we look at automation, and we look at trying to look at ways to handle changes in our environment. We want to look at making sure that we have automation in scaling, automation in recovery, automation for your deployment scripts, and your customized reporting, and so on. So these are things that we want to make sure that we have in place. We try to take advantage of the automation whenever we can, because basically we are all human and we do make mistakes, right? As we move and we look at IAC, which is quite commonplace these days, and everyone is moving towards either Terraform or CloudFormation to make sure that you can actually script your environment, you can recover quickly, but at the same time you can make your changes, and their changes are somewhat uniform. But even with Terraform and some CloudFormation, there's still the need to police the environment to ensure that what you're putting out there conforms to what your organization's policies dictate and mandate, right? So we can have policy as code, as we do in the infrastructure as code, right? We can have security as code, where we actually are enforcing some of the rules that govern the security of our environment to make sure that, again, we're not making mistakes. But if not saying it can never happen, but the idea here is to minimize the risk of these things happening. And along with these changes, and we know that basically that the sole process of change is required. But as you make changes over time, a lot of the infrastructure drifts, right? They go from starting out as secure as possible because this is new. We look at everything. We look at everything through Microsoft. We look at this fairly granularly. But as time goes by, we tend to lapse a little bit. And as we lapse a little bit, things actually slip through the cracks. And drift as code is actually there to protect your configurations to make sure that they stay on track, right? It's important. As the mistakes you make a little mistake today, you make one minor error today, you make another one a month from now. Over a 5-year period, you'd be surprised how many holes are in systems that we encounter. Because nobody actually goes back and nobody's actually policing the environment in the granular way that they should be. And on top of drift as code, remediation as code is something that we should be looking at implementing as well, too. And this is essential because we want to make sure that if something actually occurs, we can curtail that fairly quickly to make sure that if the incident does occur, we catch it quickly and remediate it quickly so that it doesn't provide a long-term exposure that basically puts us in an awkward position for data breaches. So the thought I want to leave the group is we tend to be somewhat complacent, right? And that's a problem I see on an ongoing basis. We tend to look at things and we tend to look at it like we started out fine, we know where we're good, but we don't follow through. We don't follow up with it. And as the environment changes and the technology changes, we don't adjust in order to take advantage of those changes. But again, we don't adjust our environment to ensure that we are protected against some of the things that are there, because the vulnerabilities are always there. They will never go away. But unless we remain vigilant and stay on top of the changes and adapt, we will always have problems.
So what is the number one thing you want to leave this group with? If they remember one thing.
Never assume that your environment is safe.
That's a great thought.
You're probably better off assuming it's unsafe.
Exactly. Because if you assume it's unsafe, you will always be looking at your controls, right? You will always be checking and double checking to ensure that you are safe. So it's an ongoing process, but I always say people become complacent. Never assume your environment is safe.